Hey there guys, this is Mr. Herbst here, and today my focus is going to be on the digestive system. Now, the function of the digestive system is to break up food into smaller molecules so that it can be absorbed into our bloodstream, and eventually the energy and the nutrients in the food can be used by our cells. Now, here is a picture of that guy from Man vs. Food, Adam. He is munching down on some food, more food than any human probably needs in a day. What he's doing is he's utilizing his digestive system to break down that sandwich right there into individual molecules so that he can absorb it into his bloodstream and his body can use the nutrients in the food. Now, there are many parts to the digestive system. We're going to work our way from the top down. It all starts in the mouth. The mouth has teeth. Teeth chew and tear and crush up food into sort of this paste or this little ball, the bolus, which is easy to swallow. In the process, your mouth adds saliva. In saliva, there are enzymes, particularly amylase. Amylase is an enzyme that breaks down sugar. Now I know, it breaks down starch. Now I know this is going back a long way, but remember back from our biochem unit, the starch is a long chain of glucose molecules. And so if amylase has the ability to cleave off those little bonds in between the starch, you're going to be left with just the individual glucose molecules. If you ever want to test the reaction of amylase to starch, eat a cracker. Crackers are primarily made of mostly starch. Starch doesn't really taste sweet. In fact, it doesn't really taste like anything. When you chew it up, eventually, that cracker will start to taste sweet if you chew it long enough. So, after the food is swallowed, it's going to pass into the esophagus. The esophagus is sort of like a little food tube, the connection between your mouth and your stomach. This is really important to understand. I'm going to put a star next to this. The food doesn't just fall down. It doesn't just fall down due to the force of gravity from mouth to stomach. It's pushed down through these muscular contractions called peristalsis. Now, once the food is in the stomach is going to churn up that food into this stuff called chyme. Chyme is sort of like this mushy, pasty, mucousy, liquidy stuff that no longer would look like food, but it's mashed up and ready to be digested further. Also, the stomach adds in some digestive enzymes that help break down food into its individual nutrients and allow us to ultimately absorb those nutrients into our blood. So here's a picture of the stomach. Food will enter into the stomach right through this tube right here, coming from the esophagus, and it will be greeted by this bath of acid and other enzymes that will start to break down that food. The acid is actually very important for helping to keep your body clean and healthy. The acid is strong enough that it actually kills a lot of viruses and a lot of bacteria and a lot of parasites, so that they don't, actually harm you later on. Now, the stomach is sort of like this bag of muscle. It can churn and move in three different ways. It can move in and out, up and down, and left and right. It's going to mush up all that food and mix it with that water and acid and produce this stuff called chyme, which once again is like this liquidy, no longer would look like food at this point. Now, moving from the stomach is the first part of the small intestine called the duodenum. The small intestine is primarily where most of the absorption occurs. You can absorb a little bit of the nutrients out of your mouth, and some nutrients can cross over the stomach into the blood. But pretty much most of the absorption occurs in the small intestine. The small intestine is lined with these little things called villi, which are like these small little finger-like projections, or these small little finger-like hairs that increase surface area and speed up absorption. Now, here's a little cross-section of your small intestine. All along the lining of the inside of your small intestine are these little villi here, and inside those villi are lots of capillaries that will absorb nutrients out of the food that you ate. Also, in the duodenum, or the first part of the small intestine, leaving the stomach, the pancreas is going to add in a whole bunch of enzymes and compounds that will help to aid in digestion. The pancreas actually doesn't hold food, but it adds in things that actually aid in digestion. One of those things is that it neutralizes stomach acid. Now, your stomach actually has a pH of about 2. That's pretty acidic. Battery acid is about 1.5. So your stomach is pretty acidic. And that acid is actually so strong that it actually can hurt other parts of your digestive system. If you ever had heartburn, it's because that acid backed up into your esophagus, and it's pretty painful, right? Well, if you ever had like a sore stomach, that could have been due to also acid ending into your small intestine. Now, the pancreas adds in some things that are sort of like Tums that help to neutralize that acid, bring that acid back up to a pH of about 7, so it's no longer harmful. The pancreas also adds in lots of enzymes that help to break down proteins, carbs, and lipids. Now, also at the same time, the liver adds in bile. Bile is sort of like soap, which dissolves fats into water. Now, if you've ever taken oil and water and put them in the same container, you know that oil and water separate. Fat is oil and water, well, water is water, and they don't mix. Now, bile's job is actually to help to dissolve that oil into the water, or dissolve that fat into the water. We do that because we want to absorb the fat and use the fat as fuel, as food. Now, the last part of your digestive system is called your large intestine. It's also referred to as your colon. No more really digestion occurs in your colon, which is this organ right in here that goes up and then across and then down. But the large intestine is very important for removing water out of the undigested material. If you didn't do that, you would lose too much water as waste, and that would ultimately lead to dehydration. So it helps to reabsorb water back into your bloodstream and keep you hydrated. All right, so here's a diagram of the digestive system, starting with where you eat it to where you leave it. So it all starts over here in the mouth. Food will enter into the mouth right here. Saliva will be added. The amylase will be added, which will start the digestion, the chemical digestion of starch. Now, when you swallow, you push the food back into your pharynx. Also, your epiglottis will move up and help to make the food go in one direction so it doesn't go down your windpipe. So the food will travel down through the esophagus. It will be pushed down through those muscular contractions, once again called peristalsis, and it will enter into the stomach where it will be greeted by a bath of acid. The stomach will churn all that food into chyme, and that chyme will pass through into the first part of the small intestine called the duodenum. And the duodenum is where the enzymes and the neutralizing compounds from the pancreas get added in, help to neutralize that pH, bring it back up to 7 so it's not so acidic anymore. And then also the liver will add in bile, help to digest those fats, and then all that stuff will pass through the large intestine and be absorbed by all of those little villi, and eventually will add into the food well, it's no longer food at this point, but the remaining compounds, the undigested and unabsorbed materials, will go into the large intestine here, and they will be all the water will be sucked out, and then it will pass on through, and whatever's left over, whatever solid mass is left over, gets stored in the rectum right here until the rectum fills up, and then at that point, it's ready to go, and then it will leave the body out the anus. Anyway, here, guys, that concludes the digestive system. This is Mr. Herbst. Make sure you complete the Google form below, and I'm signing off, folks. Y'all have a nice day.